Hello and welcome back to Ganesh Institute channel. So in today's video we are going to discuss about rectangular hyperbola. So basically we are taking up a question and we'll see how we can get or prove a particular equation as an equation of rectangular hyperbola. So let's see. Here you can see that a question is given. Prove that the plane z is equal to 0 cuts the enveloping cone of the sphere. This is the equation of the sphere, which has the vertex in three axes x, y, z in rectangular hyperbola. So we need to prove that this equation of the enveloping cone of the sphere is a hyperbola, rectangular hyperbola. Okay, so what we do usually, if we draw a rectangular hyperbola in xy axis, then this is how it shows. And the equation of a rectangular hyperbola is something like this: x square minus y square is equals to a square, right? So that means if we have to prove a particular equation as rectangular hyperbola, then we need this equation, right? So first of all, let's come to this question where equation of sphere is given to you, which is x square plus y square plus z square. You can take this 11 onto the left hand side minus 11, right? This is your equation of a sphere. Now what are the points given to you? So with these points you can find out the general form of sphere, which will be if you place x as something like x1, y1, z1 minus 11. Okay, so if I place x1 as 2, y1 as 4 and z1 as 1, so what I'll get, this will be something like this, right? 2 to the 4, 4 4 is 16 plus 1 minus 11, which is 21 minus 11, 10. So your S1 is 10, right? Now, there should be, because it is an enveloping cone of the sphere, so there should be a factor T also, which will form from which can be derived from this general form and particular x1, y1, z1. That means what I'm trying to say is, if you modify this equation, there are 2x, 2y, 2z, right, in multiplication. So you can write it as x, x1, y, y1, z, z1, where x, y, z are general and x1, y1, z1 are particular terms or points which are given to us. So this is x1 plus y1 z1 minus 11. This will be the equation of that enveloping cone of the sphere. Okay, this is how you can derive it. Now, whenever you have to substitute all these values, there is a particular equation which is ss1 is equals to t square. This is the equation of the enveloping cone. Okay, now if you substitute all those values in it and see whether it can form hyperbola, rectangular hyperbola or not. So S is x square plus y square plus z square minus 11. Your S1 is just 10. Then is equals to t square. T is this x1. What is x1? 2. So 2x. What is y1? 4. So 4y. And if you place z1 as 1, so z minus 11 whole square, right? You can bring this onto the left hand side so as to make this possible. The coefficient of x square, coefficient of y square, if we can have those as a constant thing, because z is 0, right? So let's see how it will turn up. X square plus y square minus plus z square minus 11 into 10 minus, you can take here 2x plus 4y plus z minus 11 whole square, right? You can expand it 10x square, 10y square, 10z square minus 110. Then you can expand it a square plus b square plus c square whole square. You can expand it, right? But whenever you will expand it, you will get 2 2x whole square, that means 4x square, 4y whole square, 16y square, then z square, and so on so forth, right? Why we are not calculating it further? Because what we have to prove is a rectangular hyperbola, and for that we need, because it is meeting the plane where z is 0, it is cutting down the plane where z is 0. If we substitute z as 0 here, so what we'll get? 10x square, 10y square minus 110. You can substitute it here also, it will be much more easier. Minus here 4x square plus 16y square, and all the terminologies which are having z are 0, because we have substituted z as 0, right? It is the condition given to us in the question. Now, in order to be a rectangular hyperbola for this curve, we need the coefficient of x square plus coefficient of y square as 0, right? Because if you see here, there is no, there is only one as coefficient of x square, one as coefficient of y square. So if we take or sum, because this is minus 1, so 1 minus 1 is 0. This is what we have to prove, right? So what is the coefficient of x square here? 10. And what is here? Minus 4. So 10 minus 4 is the coefficient of x square, right? What is the coefficient of y square? 10 minus 16. So 10 minus 4 is 6, and 16 minus 10 is minus 6. So we have already got 0, which means the question is proved that this particular equation of the enveloping plane, is a rectangular hyperbola. And how we have solved it? By having this concept that coefficient of x square, the summation of coefficient of x square and y square should be 0. I hope you understand this topic. And if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.